context, just for context, I'm not sure if we discussed this, but that
Hello, everybody.
we wanted to do graph
Thank you for tuning in to the On-Chain Safari series. Today we have a very special guest. Crypto Wanderer is his name, but if you don't mind, I have to call you Andy sometimes because that's what comes naturally. And we also have the Ugandan Decentricode community tuning in from Uganda, from Kampala, the Aya Labs from Accra, and a new guest today, the African Blockchain Club, right from South Africa. As you guys all know, these series are meant to allow us to connect with one another and give an opportunity for us to get to know the different African Web3 communities that already exist, and then also give us a chance to learn together, like learn in community. And so today I'm actually super excited because usually people ask me, what's your Web3 journey? How did you first get started in this space? And I credit all of my beginnings to Kernel. And most people don't know what Kernel is, so I thought I'd start off by asking you, Andy, what is Kernel, and what is your story behind starting Kernel?
Interesting. Okay, cool. Yeah, my name is Andy. Thank you so much for having me. It's really cool to be with folks in Kampala, Accra, and Johannesburg all at the same time. I myself am, and Kenya. Nairobi, I assume, has just joined the party. Lovely to have you here too. My name is Andy, and I am based on the east coast of South Africa in a very rural little town with about 1,000 other people. Kernel, what is Kernel, which is the question that Coco posted to me just before the Kenyan folks joined us. Kernel is the answer to about 10 years spent in and around cryptocurrencies trying to figure out what it is all about. I started getting really interested in Bitcoin with some friends just out of school in around 2013 or 2014. And I began some work on Bitcoin when this strange Russian-Canadian kid started proposing ways in which we might think about generalizing Bitcoin script and making something like a world computer out of it. I found that to be kind of crazy, but really interesting. And so I ended up in Ethereum, and in particular, I ended up working for a group of people, or with a group of people who were trying to get light clients working on Ethereum. Because coming from Africa, it was really important to me that meaningful participation in the network, i.e. being able to validate all of the transactions oneself and contribute right to right new state. That kind of meaningful participation needed to be possible without crazy amounts of hardware and without enormous data costs. And of course, if you look at the history of Ethereum since those heady early days, that has not been the case. We failed. The work that we were doing at Status has had a lot of other very interesting consequences, but state bloat, i.e. the rate at which Ethereum grew, outstripped any of our capacity to fit it onto an ARM chip or a watch or a Raspberry Pi in the sense that I mean, the meaningful participation, right? There was a lot of work that happened around the light Ethereum sub protocol and Whisper and various other things, which we will not be discussing today. But this thing of meaningful participation was really at the heart of a lot of the technical work that I was doing. And I ended up, after sort of 6 years of trying to figure out how to enable meaningful participation for people from the place where I come from, this rural village in South Africa, I sort of took a step back from that technical work and decided, well, one hand, we need all the technical work to enable the networks that we use to genuinely be usable and cheap and accessible, because it's one thing to speak the language of accessibility and transparency. It's quite another to deploy that into the real world in a way that actually serves communities of the kind that we know, love, and participate in. But the other part is education. It's also not just enough to solve the technical problems, if indeed they are solvable. One needs not just better technology, but a community capable of understanding what meaningful use really is, and not capable of just understanding it, but forging their own meaning, right? That was the thing that I was really most interested in. It wasn't kind of delivering a packaged educational product that said, look, here is the answer, this is what a blockchain is, and this is what you can do with it. It's in fact an entire program based in dialogue, because dialogue is the primary means by which we learn, which is something that has been known and practiced in Africa since time immemorial, and which seeks to think together about the ways in which blockchains might be used by people like you and me, right? Not just by weird Russian Canadian kids who happen to grow up around computers and high-speed internet connections and an environment which just these things naturally work in from their early days. And so Kernel is the result of that. It's an 8-week educational program based in dialogue, trying to get people to engage in some of the fundamental ideas behind blockchain, which is meaning, value, freedom, speech, money, governance, censorship resistance, learning how to learn, scaling ability, this kind of stuff, freedom. Really, everybody has a notion of what like trust and freedom and value and meaning are, but it's only when you examine that in dialogue with another person, grounded in the context of something like a blockchain, because it gives it, practical impetus, that you can begin to explore together what these networks might be used for and how they might serve us, rather than just becoming another technology that, we sort of rise and grind for every morning, and which forces us to be good little capitalist producers who, bow to the system and say, thank you very much for whatever crumbs fall off the table. So, yeah, Kernel.
That is Kernel in a nutshell. When I describe Kernel, I always say that the best part about Kernel is that the basis of Kernel is these kernel conversations, and learning in conversation is one of the most profound ways to actually get all the tangled concepts in your head actually makes a little bit more sense. When I meet anyone that has participated in Kernel, we can always agree that, Andy, you are one of the best communicators and most excellent writers. I'd be curious, how do you think that came to be, right? Did you tell us a little bit more about your story, and then we can dive into the reason that we're all here.
Yeah, absolutely. I think we should get to that reason as soon as possible. I mean, my story is especially why am I a good writer and communicator? Because I was very privileged to receive a very good education. And I was enormously blessed to come across a number of teachers in each of the institutions that I ended up in, who not just cared about imparting the subject matter that they were hired to pass on, but inculcating a certain attitude towards learning and a certain love for it, which is the real teacher's calling and gift. That particular privilege is the result of a long and bloody history, especially in South Africa, but one which is writ large across the whole continent. And it's worth acknowledging that and understanding that a large part of what Kernel does, and a large part of what motivates me personally, is trying to figure out healthy and constructive ways to use the privilege which I have been born into in order to give back, right? I have a wonderful friend, Yosef Ayele, who was born in Ethiopia, grew up in Tanzania and Kenya, has been all over the world. And Yosef and I have discussed at length the difference between approaching that which one is given with a sense of guilt and aversion versus letting the gift flow through you into, a more giving way in the world. And so, Kernel is done for free for the most part, and certainly like all of this stuff is in the guise of a gift, because I'm one of the
Can you guys hear me? I think we might have lost Andy. Yeah, we can hear me. Thank you, ABC. Kenya, you can hear me? Well, welcome to Africa. Something with the power has clearly impacted Andy. That's okay though. In the meantime, I'm really. I was just telling someone that it took us 5 tries to get. And every single week there's some kind of internet struggle, but that's okay. That's I think the nature and the beauty of working in Africa, and some of the questions that we'll actually ask Andy, because a lot of the times people assume that when you're running a node, that if you lose power, you might lose all of your stake, right? And so that's some of the things that we'll touch on in the next part of the conversation. We'll just give Andy a couple minutes to rejoin.
What she wants to do,
This also, like, I know there's a little bit of background noise for me. Can you guys hear me well? Yes? Okay, great, because there's can't stop people from talking around me. Okay, well, this is a good time to give my announcements as always. So the first thing, like I've shared last week, is that the Web3 Lagos Hackathon registration form is up. It allows you to participate in the hackathon virtually, and winners of the hackathon will also win tickets to DevCon. As you all know, DevCon is the... Oh, we got Andy back. But as you all know, DevCon is the largest Ethereum-focused event on the continent, it's now in Thailand this year. And if you have an African passport, we advise you to start preparing for your visa process as early as possible. So 1, getting a passport; 2, understanding the process for which you need a visa, and then 3, figuring out the different ways that we can get you to DevCon. And one of the best experiences to learn in conversation is to be physically around the builders and yeah. So now that Andy's back, I will bring him back on. Hello, Andy. Still some issues, but that's okay.
It was just purely stupidity, and let's just talk about it. Without much discussion.
Okay. A second announcement while we wait. If you are... Oh, yay!
There we go.
We're back. The joys of being in Africa.
Indeed.
Yes. Yes. Well, we can actually jump right in, because one of the questions that I always get about running a node is that what happens when the power turns out or turns off? And that is a joy that we've all had to experience, right? So what happens to your node, Andy, when the power turns off?
It stops. Just like I did. Okay, so I think just to set some context for this, I want to kind of like go over the broad landscape and then like dive directly into this particular question, because thinking about what goes wrong is a wonderful way in which to think about how to build resilience infrastructure. And so just so that everybody has the background for this, I ran Ethereum node in the early days on my laptop when it was possible to still do that, the early versions of Geth, when Ethereum was proof of work and the network had not grown in any kind of size, so it was possible to keep all of the states on your disk and off you could go. But these days, and for a long time, it hasn't really been possible to run like what are called like archive nodes, like the really, really big nodes that keep everything on about the chain, not just the transactions, but the logs associated with them and everything that you find on a blockchain. Those have gotten to many hundreds of gigabytes, maybe even into terabyte levels, the archive nodes. And the full nodes generally take kind of up to terabytes these days. Geth and what are called the execution layer clients have implemented something recently called state pruning, which generally keeps them around like 600 gigabytes. But unless you have a 600 gigabyte SSD on your laptop, that's a solid state drive, it's very difficult to do this stuff from consumer level hardware. And what that means is that if you want to run nodes on Ethereum, even though an enormous amount of work has gone into making it possible for individuals to do this and to get involved in what is called solo staking, you still need, generally speaking, to buy like fancy machine for yourself. So lots of people in North America or in Europe or Canada, places like this, they will like buy a specific machine, either their own server or something specifically crafted for this purpose. An example of a machine that is specifically built to be an Ethereum node is called DApp node. If you're ever curious, DApp node builds machines with the specs required to store all of the states and connect to the network and everything else that you need. But generally speaking, if you're thinking about running Ethereum on your laptop, it's not really possible. So if you lost Wi-Fi like I just did, that would obviously cause problems for you. But it's not really a big problem because running it from your laptop these days is really not so much of a possibility, at least if you want to run a full node. Now, the landscape has evolved a lot since 2015, which is when Ethereum launched, and I don't want to go into like a full history of it, but in 2020, there was this major shift from proof of work to proof of stake. And in terms of running nodes, the thing that this resulted in is instead of just having to run Geth or Parity, which was another node that was built back in the day, or Aragon, on these kinds of things, you now have to run two pieces of software at the same time. One is called the execution layer, and that's the old Ethereum one, and that's Geth or Aragon or Besu or Reth is the most recent one, Rust Ethereum, that was built by Georgios Konstantinopoulos and the team at Paradigm. So that part, the execution layer, often called EL clients, is the part that is responsible for executing state transitions, right? It's the old Ethereum layer one from proof of work days. And that is where the most data sits, right? So like when I say that it generally takes about 600 gigs on an SSD to run a node, it's mostly as a result of the database for your execution layer clients. And as I say, the options there are Geth, which is the most widely used. Then there's Reth, which is the newest one. And if you listen to crypto Twitter, it's the fastest, the most shiny, built in Rust. Everything is wonderful. We love Rust. If you're a serious developer, why are you using any other language? But if you do care about this stuff, beware, because while I am a massive fan of Rust and the work that has gone into Reth, there are some gotchas. And in particular, if you're very curious about this, the state root calculation function in Rust is much, much slower than it is in Go, which is curious and interesting to notice. So if you're thinking about running a node because you want to do some high performance stuff, and I'll talk a little bit about MEV, which is a phenomena that has appeared over the last sort of 5 years, then Reth is a good option, except if you're trying to do state root calculations, which sometimes people do. So that's the execution layer. You have about 5 options. Geth is the most popular. It's therefore the one that we discourage you from running, because we really like to try and have client diversity. Because if there is a bug in Geth and more than 60% of the network, or more than 66% of the network runs it, then and all Geth nodes crash, then we could potentially lose finality on the chain, which is not something that we would like to see. So if you are thinking of running your own node, I strongly encourage you to consider alternatives. And while I don't want to be particularly partisan, Reth is like the latest and most shiny one. You might consider doing it if you want to work at the bleeding edge and if you like Rust. Or I would consider the Aragon clients, which is built by the Nethermind team and is one of the most efficient, and certainly it syncs much more quickly than Geth does, and it compresses the data in an efficient manner. That means that its database is probably the smallest, along with Reth. They kind of vie for those. So if you're really looking to try and optimize on data costs and this sort of stuff, Aragon is probably your best bet if you're not going to use Geth. The reason that you would want to think very carefully about data costs is because it's no longer really possible to run this stuff on consumer level laptops that are readily available in Africa. Generally speaking, you will need either to use a cloud service provider or to, as I say, like run your own like specifically tailored machine in your own offices, or in a friendly data center close to you. If you can find some friends with a big garage in Nairobi or Kampala or Accra, then that's wonderful. I could not do that, and so when Ethereum 2, the proof of stake version, got going in December 2020, I really wanted to participate because I love the narrative of solo staking. I love this idea of lots of different people with lots of different politics and lots of different ideas, all running nodes from all over the world and participating in the network. It had been what I was working on from the very beginning in the sort of light clients research and implementation work that we were doing. And even I couldn't run my own machine because South Africa has really, really bad power cuts. We haven't had power cuts in like the last 150 days, which is amazing. But at the time in 2020, we were in like stage 6 to 8 load shedding, which generally meant about 8 hours without power every day. And so it wasn't possible to run a node from my home. And I'll go into the reason for that in just a little while. There's just a bit more context to say, which is that as a result of not being able to run one of these nodes from my home, I used the AWS data center in Cape Town. And this is why you want to think very carefully about data costs, because when you use like a cloud service provider like AWS or Google Cloud or Azure or Hetzner or any of these options, generally speaking, you're charged for the kind of computer that you run it on. In this case, I was running it on a T3 medium AWS machine. If that means anything to anybody, it's 8 gigabytes of RAM, no, sorry, that's for the consensus layer, which I'll get to. It's a bigger machine for Geth. And the thing that was costing me the most was not the compute, not what you pay for the actual like kind of computer. The two biggest expenses were data, the input output, like the actual internet costs, so to speak, right? Your data costs to communicate from the center in Cape Town, and storage. In this case, it's called EBS it's elastic block storage for AWS, and Google and others have different names for it. But storage and data were the two big costs. And to give you a ballpark figure, I was quite careful about how I set up my machines, and I really used the minimum possible machine that I needed to keep up with the chain and keep my nodes in sync. And it was costing around $500 a month in AWS. And this is the other point that I wanted to make, and I've never been able to make it because Amazon doesn't listen to people like me. But the problem with doing, I wanted to use the data center in Cape Town because I care about geographic centralization and I care about running stuff from Africa. But the data center in Cape Town is more expensive than US East 1 or US West 1. If you've ever used Amazon, you'll know what I'm talking about. Like, those data centers are the cheapest to use, whereas the one in Cape Town has just recently been set up and it just costs more. The data is more expensive, and for some reason, EBS is more expensive in Cape Town than it is in some of the other zones that Amazon have set up. So there was an additional cost, and that's why I was paying about $500 running both my execution layer clients, which we've discussed already, the one with the big database, old Ethereum one, the one that executes the state transition functions. There's 5 different options, and my consensus layer clients. So these are the 2 pieces of software that you need to run. The consensus layer clients were added for Ethereum 2, the proof of stake version, in December 2020. There are also 5 options. You can run Prism, Lodestar, Nimbus, Teku, and Lighthouse, is it? I think, yeah, Lighthouse, Prism, Teku, Lodestar, and Nimbus. I ran Geth because I was very familiar with it as an execution layer client, and I ran Nimbus as a consensus layer client because I worked at Status, and they were the people who developed the Nimbus client. It's not one of the most popular ones. It's written in a new language called NIM, and is specifically intended for resource restricted devices like Raspberry Pis or ARM chips or this kind of stuff. And the consensus layer client is what's, it communicates the relevant consensus information, the headers and the signed headers and all of that kind of stuff that are required to, make sure that nobody misbehaves and that the network stays in sync. The 2 things communicate, the execution layer and the consensus layer communicate via something called an engine API. And so, your consensus layer client passes information about consensus back to the execution layer clients, and it executes the state transition functions and passes that back to the consensus layer. There's one other thing, and I'll be happy to provide links and extensive documentation about all of this, because it's very difficult to absorb the whole thing just in a spoken presentation, and there are wonderful resources around all of this. But the other thing to be aware of, because it will be something that I think we'll discuss a little bit later, which is that I actually also run a 3rd piece of software, execution layer, consensus layer, and then a sidecar. Imagine I'm trying my best to keep this kind of motorbike on the highway and keep it running in Africa and avoid all the potholes, and try and figure out where to put it so that it avoids power cuts and these kinds of things. The data centers have dedicated power supplies, so that's why I ran it there. You can imagine it like a sidecar to that motorbike, navigating its way through all of the things. And this little sidecar is called Mev Boost. And what it does is it outsources the role of actually building blocks to professional actors. And that's because building blocks is a highly profitable endeavor. It is best done by very, very sophisticated teams, and Mev Boost allows, whenever I get randomly selected, whenever my consensus layer client gets randomly selected to propose the next block or to be on the committee that does that, it outsources the actual block building via a relay to one of these block building parties who will build the block for me and then communicate it back to my validator and allow my validator to submit it to the network. And then we share the fees associated with that. That's now become common practice. For a very long time, I avoided doing that because I hated the idea of outsourcing the stuff and kind of giving it to another 3rd party. And we can talk, Kokeb, about the centralizing forces at work in block building, because it is relevant to running a node and it's relevant to the profit that you can make from doing so. For a long time, I avoided doing this because I was taking an ideological stance. I was running my node in Africa. I was paying extra for it to be genuinely done in Cape Town. And there was not a chance in hell that I was going to outsource the stuff via a piece of software built for an organization which I now work for, called Flashbots, because at the time, Flashbots had implemented OFAC sanctions. So any address that had been sanctioned by the Americans was not, any transaction from one of those addresses was not processed. And I was having none of that, and I was willing to forego some of the profits, because when you do outsource this to other builders, you're more likely to land blocks and therefore get the fees associated with those blocks. And I was willing to sort of forego that and just hope that I could land a block as a solo validator, because I didn't want to. I don't necessarily agree with all of the decisions that American bureaucrats make about who is a terrorist and who's not. And I have since started running that piece of software only once they open sourced it, and a number of other people began running these kinds of relays that and do not implement the OFAC sanctions.
So maybe just to dive a little bit deeper into the philosophical, the ethos reason, right? For someone that's new, that might not understand what an Ethereum node is and how it contributes to decentralization, can you touch more on that and why your decision making was forego profits for that ethos?
Sure. Yeah, because it runs deep, right? It goes right to the heart of what it is that we're actually trying to do. And one of the most underappreciated aspects of building a truly global network to do open finance and any other thing that you've heard blockchains touted as being able to achieve is that you absolutely need geographic decentralization. You need people in different jurisdictions and who are subject to different regulatory overhead running these same pieces of software. Because if, for instance, the American government decides to change the laws about what constitutes a security, or who is considered a terrorist, which country is being sanctioned, what addresses that have interacted with which protocols are considered blacklisted, then you can't have a truly open and global financial system, right? Like if the vast majority of people who are participating in this network and who are ensuring that we continue to make blocks and progress along the chain are subject to American law in this particular case. But the same is true, if it's in India where another whole bunch of nodes are run, or across Western Europe where the other major concentration is, then the network is not truly global, and it is brittle to regulatory changes, right? And that's precisely the kind of thing that we want to avoid, because what we're seeking to do here is to create shared and public goods that are executed by virtue of agreed upon consensus rules, right? Now, I'm not necessarily saying that code is law in a completely one-to-one basis, but what I do care about is a certain kind of predictability and an openness, right? That is not subject to the whims of whichever bureaucrat happens to be in power. I think that it's very important that we understand that code, even though it is executable and is much closer to maths than natural language, it's still you can still change it, or it's still flexible, and to some extent it's still ambiguous. It's not as ambiguous as natural language, so it's not quite like a one-to-one mapping with code as law, but it is really, really important that if we do build global systems, they are not subject to the ambiguous interpretation of one particular group of people, whoever that happens to be, right? I don't necessarily mean to call out the Americans or any other particular government of this, because every government has their good and bad points, and that's been a long lesson for me. But there are so many aspects to geographic decentralization which matter, because the other part outside of like just regulatory resilience and being able to implement a truly global financial system is that like this is where we beat TradFi, right? Like traditional finance is by having a system where the sum of the parts is greater than the whole, and which does truly serve people everywhere, irrespective of like particular regulatory climates and irrespective of like, especially like latency, because that's the other part of this. Like that's what I've just answered is more because you asked it in a particular way, like the philosophical and legal implications of this. But there's a whole technical branch as well, which is that, for instance, if you look at the way that the builder market works these days, the people who actually build blocks, and there are 5 of them, right? In fact, 3 groups build more than 50% of all blocks on Ethereum: Beaver, Titan, and rsync. They all co-locate with the relays. And what that means is everybody knows everybody, and so they message each other in Telegram, and they're like, "Yo, Justin," again, I don't mean to pick on anybody, but "Yo, Justin, where does ultrasound relay run?" And he's like, "Oh, like some data center in Europe." And then they go and co-locate with that relay, i.e. they put their builders on the same rack in the same data center as the relay so that they can absolutely minimize latency. And this is the same thing that you see in traditional finance with what's called high frequency trading. It's why the rent on the fiber optic line that links Chicago and New York is so much higher than it is anywhere else, because if you're on that straight line between Chicago and New York, you get 10 nanoseconds advantage over your competition, and so can execute trades more quickly than they can. Exactly the same thing is happening these days with block building on Ethereum. And it is yet another reason at a technical level, outside of the regulatory and legal aspects, to think very carefully about geographic decentralization. Because if there are lots of people all over the world running nodes and contributing to the way in which the network achieves finality and moves forward, then it becomes much, much more difficult to do that kind of stuff. And the economics of it change. Because at the moment, if there's only a few people running relays and if there's only a few builders, then it's very, very much profitable to find out where these things are and to put a builder here next to the ultrasound relay and a builder here next to the flashbots relay and a builder there next to the agnostic relay. But if you have lots of solar stakers all over the world and lots of different relays and all of these kinds of things, then all of a sudden the economics are very, very different, even if some of the market structure is still kind of the same. So it's a multifaceted thing. Geographic decentralization really matters. It is, in fact, in some way, the fuel for creating better engines that actually harness like all of the financial energy available and distribute it in the most efficient way, where like efficient is defined as that which aligns user outcomes and advances chain security, both under conditions of economic conflict. So that is to say that, like these global networks present real challenges because you have people who are constantly in adversarial relationships. And I don't mean that they're trying to attack each other, but like trader A and trader B both want to trade against coin C, but different ways, charging different prices. And they both submit transactions to make that trade. How do you decide which trade gets executed and who gets the proceeds of the trade? That's like conditions of economic conflict. And what we need is better mechanisms for like harnessing all of the financial information available in the fact that trader A and trader B both want to trade, but at different prices on point C, and ensure the most efficient like market structure, that i.e. that like they both roughly get what they want and that nobody else is harmed in the process of that happening. That can only happen with geographic decentralization, right? Because if you don't have it, then you will inevitably have a few powerful people sitting with pieces of software that everybody wants to co-locate with, who get to make the decisions about what fair ordering and this kind of stuff looks like. And that's really problematic. So yeah, that's a little bit further than running a node. I'm sorry, but it's
But we also
You had cut out just at the last part. Yeah, okay, great.
Yeah, the thing of geographic decentralization really matters, and it's the whole, like that's why this counts, right? Like that's why running nodes in Africa really matters. It's not just to like, it's not the old story of like, oh, we need to like empower people, and no, that's bullshit. It's a Western narrative pushed onto African people for hundreds of years, because like you need to empower yourself in ways that like are legible to like Western democracies, right? And it's not true, right? What actually matters is that there's a genuine contribution to be made from all parts of the world towards actually running a global system in which everybody's needs are roughly met under situations of natural economic conflict, because naturally we don't all want the same thing. And we shouldn't build systems that make us want the same thing. We should build systems that acknowledge the fact that we don't all want the same thing and make the best out of that they possibly can. So, I'm very passionate about this. It's like, this is not to like, empower Africans to be able to do what people in the West do. No, this is like, people in the West have been like messing up a huge amount for a long time, and like we can help. So like, let us help. But we also need to figure out the ways in which that like works well for us. So, yeah.
I've always we've been fortunate in Kenya to have the Ethereum Frontiers happen a couple months ago, organized by Yosef Fayele and the Ethereum Foundation team. We kind of interrupted their interop and did a community event. And one of the things that still resonates with me from that event is that Ethereum needs Africa, right? To truly be decentralized, to truly achieve some of the initial visionary goals, needs Africa, not the other way around, right? Africa doesn't really need Ethereum. It's Ethereum that needs Africa. And so, I've also heard an analogy, a beautiful analogy from one of the folks at the ethereum.org side of things, which is if we equate running a node or to kind of having a dinner party, right? A decentralized dinner party, and everyone has to contribute some wine to a big pot, right? And the whole goal is at the end, you all contribute a bottle of wine, and then everyone should be getting wine. And so if we think that we're not responsible, and if we add a little bit of water and no one will notice, what will ultimately happen is that the big pot will just be very watery, because we won't take that initial responsibility to say we have a part to play in contributing, right? And so I think many people here are very eager to start contributing, yes, for the philosophical reasons, but also for the financial reasons. And so I think it's a good time to kind of go into, where do you start, right? What do you need? Where do you start? And what would you recommend for starting specifically in Africa?
Great. Yeah. So I've told half the story, which is that I began by running Geth and Nimbus together on the same machine in the AWS data center in Cape Town. That was costing me about like $500 a month, and nevertheless remained profitable, because like the returns for solo staking, particularly in the first 2 years, tended to be like hover around the 4% mark in ETH, and ETH did well in those periods. So 4% in ETH was more than enough to pay for the 500 USD per month costs. But of course, the first thing that I needed, two things, were 32 ETH, because that is the minimum required to actually register a node in the Beacon Chain contracts. And I needed capital lying around to pay 500 USD worth of fees every month. So that's quite a high barrier, right? And in thinking about how I would approach this talk, there are two things that I would say. The first is that I no longer run it in the AWS data center in Cape Town, because I met some wonderful people who are also based in South Africa and who happen to run some bare metal of their own, i.e. they have dedicated servers that they control and which are in an environment somewhere in or around Johannesburg that has dedicated power and is not subject to load shedding, and which has a direct connection to quite a powerful internet cable. As generally speaking, you want at least 1 gig up and down to run a node. That's like the data requirements for this. So you need at least 600 gigs SSD, 1 gig up and down data connection, and uninterrupted power. They happen to have those things and to already be running a Geth node for their own research purposes. And they very kindly let me plug into their Geth node while I still run my own validators. And the consensus layer stuff, the Nimbus clients or Teku or Lodestar or Prism or Lighthouse, that's very, very light. There are no major storage costs associated with that, and the data in and out it's not trivially cheap, but it's not like $500 a month expensive either. So what I have done is I've just collaborated with them.
What does that collaboration look like for people who want to maybe do that together, right, as a collective? Can you touch more on that?
Specifically, the collaboration looks like them telling me the IP address of their Geth, the externally accessible IP address of their Geth machine, and sharing the JWT, the JSON Web Token secrets that allows my validator clients, my Nimbus clients, to talk to their Go Ethereum machine. So as I mentioned, the thing that mediates communication between the consensus layer and the execution layer is something called the Engine API. And Engine API calls are authenticated by a JWT, and you need to share that JWT. So they had to tell me where their Geth machine is. They had to open up the firewall on their machine, because you need to really make sure that you run a firewall on your Geth machine, because people do try to connect to them from everywhere and do funny and strange things. So they needed to open the firewall to my specific IP address that I'm running my validators from my consensus layer clients, and then share the JWT. And those 3 things allow me to then use their Geth machine as my execution layer clients while maintaining my own validators. I happen to shift my validators to Hetzner because they're cheaper than AWS. I still don't want to run them on a machine here because we have intermittent power, and even if the national supplier doesn't load shed us, there are often power faults here because we have a pretty long cable over the river that separates our town from everywhere, and sometimes when the wind blows, the power goes off. So it's still not possible for me to run my validators here, but that collaboration has been enormously helpful to me, because it has decreased the cost for me for running a validator from in the region of kind of like 16,000 Rand a month to about 600 Rand a month. So it's an order of magnitude difference, just as a result of collaborating with folks who have these machines running already. Finding like good partners is one way in which to approach this. The other way, if you are really struggling with the capital requirements, especially the 32 ETH parts, because despite the fact that ETH is down a bit at the moment that we're having this call, it's still a significant amount of money, particularly for anybody in Africa. The thing that I would recommend doing, and which I have done myself in addition to running like some solo staking, is using Rocket Pool. Now there are lots of like different services out there who will offer you the ability to, run a little bit of, you have to pull your ETH together and like run a little bit of a validator, without a doubt, and by far and away. And I really don't like appearing partisan because I think that there are many wonderful people out there and lots of solutions, many of which I don't know about. But in this particular context, I am, I have like 90% epistemological certainty that Rocket Pool is the best way in which you can go about running a validator in a meaningful way for Ethereum without the 32 ETH that you require. At the moment, you need 8 ETH. Rocket Pool is basically a means in which you can put up some part of the 32 ETH required to make a full validator. You run the software, a Rocket Pool node, and you put up 8 ETH, and then the rest, the 24 ETH, is provided by people who want to just buy R ETH and hold it, and then R ETH tracks the value of all of the nodes being operated on the Rocket Pool protocol. There's a great deal of detail that I could go into there, but they got going prior to POS being delivered. They have done really interesting work on multi-party computation. They're by far the most advanced team in this particular regard, and their software is a pleasure to use. So, I think that that's probably the most, like if you don't happen to know people who are just like running a Geth node for research purposes like me, then your next best bet is to try and scrape together 8 ETH from friends, family, and whoever else you can find, and run a rocket pool node. I want to caveat that by saying that I would only do it in about 6 to 8 months from now, because they're going through a major upgrade, and you might need, if you're really thinking about that, you might need about 6 months to find like 8 ETH. And get it together. And the reason for that is a little bit complex, but you need to put up 8 ETH, and at the moment also they have a token called RPL, and you need to have a percentage of your ETH stake in RPL there as insurance in case your node goes down. And that has proven difficult for them. Although I love the design of it, the token markets have not been kind to them. And as a result, running a node gives you some exposure to RPL, which has not been a winning bet. And that was one of the reasons that my particular foray into Rocket Pool ended about 6 months ago. Precisely because it just became too expensive to have to continue supplying the required amount of RPL to insure the node, which is still the case, but they're going through a major upgrade, which will make it no longer the case. And then it will once again be definitely the best way if you don't have 32 ETH to run a node. And I think that they will decrease the size of the ETH requirements even further to sort of 4, potentially even 2 ETH. And given the quality of their software, I think that that's a major thing. So I'll share the Rocket Pool documentation after this, and you can go through it. You can also try running it on a test network just to become familiar with it, and it's very easy to sort of get enough ETH on one of the test networks to run a node. And you can do so through a faucet or through a friend. I'll see if I can find some people who have Sepolia test ETH for folks who are interested on this call, and then you can test the software now and just see what I mean by they have the best wizard in a CLI that I've ever seen. So you can kind of have a go there and get yourself ready for whenever you are able to get 8 ETH, which again is still a massive barrier, but that's kind of the best that I have at the moment.
Yeah. So there's a whole bunch of questions in the chat. One of them that I had that ties into what Denzel was asking is, what are some of the resources or communities that are available for node runners to actually seek help and advice? Is there things like that exist? Do you know of any that you can share?
Yes. The most prominent one is called ETH Staker. They run a Discord, and they have by far the most active. They have a Reddit. They have a Discord, and probably the most comprehensive documentation. I would recommend them above anybody else. And again, you have to kind of be careful with this stuff, because now we're a few years into it, and more and more people have appeared who don't necessarily have the best intentions, or certainly your best.
I think Andy was saying that they don't have the best intentions, so do your own research. What I really love about the past 15 minutes or so and what Andy was sharing is really tied to the mission of On-Chain Safari. Having a collective way of running a node, getting those financial incentives, and contributing to decentralization, whether it's with the community in Uganda, collaborating with Kenya, collaborating with South Africa. I'm sure that there's many eager people just sitting in these 3 rooms that would want to participate. And so if you haven't already, join the WhatsApp group and actually ask who wants to take this rocket pool, like, very seriously, and organize amongst yourselves ways to collaborate on this. That's one of the main goals of bringing you all together in this fashion, because if you want to, if you don't find the people around you that are interested, I would hope that somewhere between all of these different communities that we do find people that really want to take this to the next level. Oh, yay. We're going to get Andy again.
There we go.
Hello.
This time from yeah. So thanks for that. And yeah, like each stake is the best like community. Rocket Pool also have like a wonderful Discord, and so like between those two, you should find like more than enough help. And then you'll find also that each of the consensus layer projects, so Nimbus, Teku, Lighthouse, Lodestar, and Prism, each have their own Discord, and those can also be like wonderful places to go if you're looking for technical assistance. Obviously, if you're running one of those clients, definitely go there. If you're gonna like experiment with Rocket Pool, definitely go to their Discord. You can find it like very easily from their docs. And if you're looking for like general information on everything that we've been discussing now, like ETH Staker is probably the best. If you're like more research oriented, there is like a wonderful book written by one of the people who was like very much involved. Let me see if send that. Oh, for some reason the link is not. The link is not going through, but
Okay.
it's there we go. ETH2book.info. This is written by a man called Ben Eddington, and Ben was like very much involved with the initial developments of Ethereum 2. And so if you're looking for more of the like history behind the shift to proof of stake and why things are the way that they are, that's the place. ETH2book.info is definitely like your best bet. Between those things, you should have like more than enough, and you should meet more than enough people who will be willing to help you further along on your journey.
Yeah. So we have a very bold question from one of our favorite question or curious people from Kenya. He's asking if he wanted to build a custom hardware rather than purchasing a dApp node. Have you one, ventured off on your own journey to do that, and two, what specs would you recommend in terms of value for the cost?
That's a good question. I'm not the most qualified person to answer this because I haven't done, just because where I live, it doesn't make sense to run my own hardware. As I say, like if I were building it myself, I'd get like a 1 terabyte SSD. I would, it depends. Can you hear me still?
Yes.
There we go. Yeah, so 1 terabyte SSD, at least 64 gigs of RAM. I don't know. You don't really need GPUs anymore, but like, I don't know, maybe you're like that kind of person who also wants to like play World of Warcraft while you're running a node. So like maybe, but it depends,
Probably.
But yeah. So maybe you throw in a GPU instead of like some kind of fancy NVIDIA card. But yeah, 64 gigs of RAM at least and 1 terabyte SSD are like the very salient pieces, and that'll be just enough. If you want to like run anything else on that computer, then you'll need more storage. And you definitely want to go SSD. So like those are the rough pointers that I have, but I haven't built it myself, and I don't actually know what the specs of the dApp node are. Although you might be able to find them online because they're pretty open source maxis. So.
You said that it wouldn't make sense for you to do it just because of your location. Where would it make sense to build your own?
I mean, if you're in a city, I think you're fine. In South Africa, I'm not sure. It might be slightly different in Kampala or Accra in particular. Nairobi is probably fine as well. So like any of the cities in South Africa will be fine. The particular problem that I face here is not like the predictable and scheduled blackouts from the national service provider. It's that there happens to be a very, very long span over the river to my town. And when the wind blows, which it often does because I live at the coast, that goes down. And that is for unpredictable lengths of time. And so, like you should be able to have enough power in a UPS, an uninterrupted power supply, to get through scheduled blackouts, and that'll be fine. You can do that. Or indeed, and I actually have this, you can live off solar. So I don't even really depend on like the grid all that much. But the problem, of course, that I face is that the people who do depend on the grid are the cell phone towers who provide internet connection. So when the grid goes down, then the cell phone towers go down because the batteries they fetch a really good price on like less legal places in the country, and so people have taken the batteries from the cell phone towers, and so they depend entirely on the grid. And so when the grid goes down, even though I have power, I don't often have internet. So it's a very, very particular like local problem that I have, which you wouldn't face in a big city because there's always mobile coverage, and the only power failures that you tend to see there are, generally speaking, like slightly more predictable. Although in other parts of Africa, that's obviously not the case. And then in that case, you just need to make sure that if you have like connectivity, then you just need to make sure that you've got a UPS, an uninterrupted power supply that will last for a few hours. Because finally, this gets me to answer that question at the beginning. I'm so sorry again. Oh my God. If you lose power and connectivity, of course, when node disconnects from the network, it stops functioning, right? That doesn't mean that you lose all of your stake. What it means is that you're no longer keeping up with the tip of the chain, right? And when you're not participating in the network, there's something called an inactivity penalty. The inactivity penalty is very, very small, right? And particularly if you're the only one who goes down because it's like a power failure or something, it's absolutely tiny. The inactivity penalty scales with the number of nodes who are like misbehaving at a particular time. So if it's just you and your node because like your area has gone down in Kampala or whatever, it's a very, very small penalty. The issue that you face is that if you go down for like 6 hours, which I have many times, then it can be quite difficult to resync the chain to get to the tip again. And depending on the machinery that you have, and this touches that question of like what sort of hardware requirements do I have, like this is why it's probably better to have more than 1 terabyte, to have more than 64 gigs of RAM, and potentially to use a GPU, because you'll be able to sync the chain faster. And so when you do go down, you'll be able to like get back up to speed and start participating again more quickly, such that you aren't penalized for extended periods of time. Because it has been the case in the past where I lost, for one reason or another, I got a signal interrupts on my Nimbus client, or like an out of memory error once or twice, and I didn't notice for 6 hours. And then I went and checked it, and it took me another 3 hours to sync the chain. In fact, in one case, it took me another 2 days just because of some other issues that I was having with that machine. And so like I think I lost like 0.001 ETH in an inactivity penalty. So really like not a huge amount. But if you're kind of really depending on a 4% APR in order to cover your cloud costs or whatever costs you have for running it, depending on what your setup is, then that kind of thing can really eat into your revenue. So you don't lose your stake. It's not a big problem. Everybody who has ever run a node has definitely gone down for extended periods of time. and the only thing is to make sure that you can like get back up to speed, get back up to the tip of the chain quickly enough, and that's again, it's generally possible with good enough specs, 64 gigs of RAM and maybe a GPU if you want. But there are CPUs in data centers. It's been fine. The one time that it took me 2 days was because of my own misconfiguration error, and so I can't even blame Uncle Jeff for that.
That's funny. It kind of relates to the question that Denzel had asked, but when you're facing problems syncing like Geth with Rospin or Rinkeby, why did it take you 2 days is one way of asking it, but like how do you overcome those challenges? Is there actual resources on the internet that actually help with this, or for someone that's a little bit newer and that's willing to take on this risk but doesn't really want to do it alone or like do it without some information, do you find that there's actual resources on this?
Yeah, there are. Like the Geth documentation is pretty complete, as is Reth, so far as I've seen, and Aragon. So all of those, and it's syncing the execution layer, which is generally the most time-consuming and challenging part. I think that's it's two things. Like if you don't have any experience reading technical documentation, it's still probably going to be like a major barrier because it's written in a particular style and like language that is like generally speaking full of jargon and quite accessible if you have no idea what you're doing. In fact, like there's even like I would say like a certain brand of like developer and DevOps engineer who like thinks that nobody other than other DevOps engineers should be able to read the documentation, which is something that I've spent a large part of my professional career trying to attend to. But yeah, I think that the documentation can still be a bit challenging. This is one of the reasons that like the ETH staker thing was the first community that came to mind. Because they were the people doing it at the time of the merge and even prior to providing information in those early days when it was still like the spec was kind of still in flux, and a single tweet from Vitalik could potentially shift things. They were there, and often the best place for me has ironically been Reddit. Because I don't use Reddit for all that many other things, but if you're good at Googling around, you will find like lots of wonderful things on Reddit about, for instance, the exact specs for the machines that I ran in AWS. I pulled from Reddit. There's a wonderful post somewhere on Reddit that I have saved on a different machine, which details in 2020 the exact like needs that the exact specs that you can get away running Geth with at minimum cost. And so, yeah, like a lot of these kinds of things will be on Reddit.
I don't know if you noticed, but Sid had also joined the live stream. I don't know if Sid is still around, but he touched on a question that kind of relates to the next part of our conversation on scalability. We have touched on quite a lot about how to run a node in Africa. But he asked, how do individuals and local communities grapple with the why behind Ethereum adoption, especially in the wake of other competing narratives coming from the Western world? I think it's a very powerful question to kind of lead us into the direction of talking about scalability.
Great. I literally only caught the last 3 words of that.
It's okay, no worries. I can ask it again. But Sid asked, how do individuals and local communities grapple with the why behind Ethereum adoption, especially in the wake of other competing narratives coming from the Western world? There's tons of chains now, and there's always something new. And so yeah, I was thinking that it could really tie us back into talking about scalability.
Yeah, it's such a good question. The
We can count on Sid to ask good questions, right?
truly.
Yeah.
The thing that's really kind of began it all. One of the clarion calls of Bitcoin was don't trust, verify, right? And it's a very interesting phrase because it points to the difference between those two words in English, right? Because actually, trust, the word in English, has two different roots. The one is veritas, literally, which is kind of very closely linked to verify. It's got to do with verifiability and that which you can prove. The other is trüve, which is like an old German word, and it means stability. And so, like, what that phrase "don't trust, verify" is pointing at is like, there needs to be a focus on that which you can experience and verify for yourself. Stability, that much more fluid and ambiguous human form of trust, comes through dialogical relationship. It comes through community. It comes through Ubuntu, right? There's this old African idea that I am only a human through you, right? And through the community in which I participate. That's got to do with trüve. But the thing that we're actually interested in terms of like the precise state transitions of shared networks on which we all operate is verifiability. And this is the thing, right? Like, it's like don't give a shit about Ethereum adoption. Right? And if anybody tries to sell you on it, like, laugh them out the room. And the same for everything. Like don't believe what other people tell you is the most simple answer to this, right? Like, experiment with it yourself and see where you get to. Like, if it turns out that you can't run an Ethereum node, try and run a different node on another chain, right? You'll find that, like, Solana is even harder and has higher requirements, but that there are other chains where it is eminently possible and which might better serve your needs and interests, and that's wonderful. Right? Because the point is not for Ethereum to take over the world, nor is it for for it to use Africa to meet the needs that it has for geographic decentralization or all of this. It's not that, right? Like, the real goal is kind of unspeakable, right? In some very, very deep and meaningful way. That's why we have to listen and have these conversations to try and define the negative shape of it. It reminds me of this wonderful work by, ironically, an African writer. His name is Albert Camus. I don't know if you've heard of him. He was Algerian, right? Even if he's most closely associated with France. And the best essay that Camus ever wrote, in my opinion, is something called The Ruins at Tipasa. And Tipasa is a place in Algeria. And there he says, he writes the most beautiful thing, that once in his life, standing there at the ruins in Tipasa, he was granted what all great characters in tragedy see, which is their destiny, light. Right? And he says, this is such a crowning moment, but it still has about it the ring of ethics. Right? And if we could name the truth of what I really experienced at Tipasa, what silence would ensue? It's the most incredible thing, I think, that he ever wrote. And it's what I'm pointing at here, which is that what we really yearn for, what we really want is, it's not just accessibility, and it's not just fairness, and it's not just transparency, and it's not just a lack of corruption, and it's not just the fair distribution of power, and it's not just equal opportunity, and it's not just recognition for the gifts and talents that exist in Africa. It's all of those things and then some, right? And I think that's, if somebody's trying to sell you on use this particular technology to achieve all of that, they're really they're misleading you, but potentially more dangerously, they're misleading themselves, right? Because it's not one technology that can do that. What it is every human soul taking every single step, right? And the sequence that we each take those steps in might differ. And like we in Africa might need a few more technical skills and slightly better education systems, and like some really kind of specific practical things that might help us take some of those steps. But in the same way, there is a particular mindset, there is an understanding of what community really is, which is not like everybody vibes together and like has a great time and totally agrees with one another, right? Like community is something very, very different from that. We have an understanding of these things, and we have an understanding of what dialogue is and what it can mean in the life of an individual and the community in which they participate. We have an understanding of what gifts are. We have an understanding of what it really means to experience wealth, not as an accumulation, but as something that is shared. We it's like it's still there in the culture, right? And that's an enormous, like, all of those steps have been taken here. And in some very important respect, they're much harder. So, I think that's the biggest thing is like, just like verify these things in your own experience. Is it possible to run an Ethereum node? Hopefully I've been able to give you some pointers that might suggest lines that help, but like maybe it's not possible for you, right? And that doesn't mean that like, therefore, you shouldn't try and like participate in some kind of like potentially global network. But like maybe there are just others that are better suited to your particular locality and needs right now. And I think that that's wonderful, and that you should do that. And that if anybody tries to stand in your way, then you can test the real permissionlessness of this stuff. You don't need anybody's permission. And if you do, then you know that it's probably not the thing that is really going to get us closer toward that kind of world which we all like in our hearts know is possible, right? And yet find so difficult to really like express to one another and to wrap in words, precisely because like it's the ground for meaningful words. It's not the thing that meaningful words get us to.
And yeah, I want to be mindful of your time. There's a couple more questions that are more about running a node. And also, I think when I imagined this conversation, I really wanted to touch on maybe some of the challenges that you think Ethereum is experiencing around scalability, right? I think that's always been a very big conversation in the Ethereum ecosystem. We had Justin Drake on the On-Chain Safari series a couple weeks ago, and he touched on his research and what they're doing to actively address scalability. But you said that it was your favorite kernel lesson, right? And there's so many favorite lessons, right? But what I love most about scalability is you share it in a way where it's a gift, right? That's having one tool where we all record history with this one tool, maybe not one, but is a gift to humankind. And so maybe kind of share a little bit about that kernel lesson, why it happens to be your favorite, and then we can touch on the last couple of questions.
Can we do the node questions first? Just and then we can, because otherwise, I'll just like kind of end up going on another tangent. And I really want to get to those, and then we can touch on scalability. That's okay.
Very true. So the one of the last node questions was: is it possible to have a decentralized storage setup where only one machine is running the logic and the others are used for the storage?
Not really, just because for any of these execution layer nodes, like reading and writing from the database is the most compute intense thing that they do, right? And like trying to distribute that database and have it like run over multiple different machines, it's not going to work, because you add latency to each read and write, which it won't work, right? For various different reasons. So you need to be able to like run a single Geth machine with a single unified database or Aragon or whatever it is. The important thing to note here, though, if you've not done this stuff before, is that you only need one execution layer machine, right? And you can connect a great deal of different consensus layer nodes to that, right? So these people that run this Geth machine that I use, they also have their own validators, which also use the Geth machine, because all you need from the execution layer client is like the hashes of the state transition, right? Like there's just like very specific information that you get through the engine API, but you can get it from any execution layer node which is synced with the current head of the chain, right? So you could connect multiple different CL clients to the same EL clients, the same multiple different consensus layer clients to the same execution layer. And in addition to this, in each consensus layer clients, you can run multiple different validators. So I have because I run it as a service, right? Like I have many more than one validator running on a single consensus layer client, right? So for each validator that I spin up, I don't need to start a new consensus layer client. I just need one of them, and I can put kind of up to 1,000. I think I'm not entirely sure. I don't have that successful a business, but you can run any number or a good number of validators on the same consensus layer clients, and then you can connect many consensus layer clients to single execution layer clients. So like in that sense, you can still achieve kind of what I think that question is pointing at, which is like you only need to run like one execution layer client, and you can have like multiple different validators using that same state DB that is being kept in sync with the chain by whatever execution layer software you're using.
That's actually super helpful. I didn't realize that you can have so many consensus layers and use only one execution layer. Which
So your compute costs do not scale linearly. That is it costs a lot to set up one node, but almost nothing after that to add arbitrarily many validators. But of course, the cost is in the 32 ETH stake required.
Yeah. And then earlier you touched on a little bit about firewalls, but there was a question around what security measures should we implement to protect our nodes from attacks?
Yeah, like a firewall is like a must.
The answer.
It's just a must-have. I mean, it's like a whole separate lesson, I think, basically, because you can be like really like tinfoil hat about it, or you can just be like kind of like a wish and a prayer and basic good practices. So there's lots of different firewalls out there. I think like one of the most popular ones to use, especially on Linux-based distros and like cloud machines, is something called UFW. There are also others you can use, like older versions like IP tables or whatever. UFW should be able to do what you need. And like the very basics are like create a proper user group. Don't just have like pseudo access for the like user that is running your software. I mean, that's like a basic like Linux 101 thing, is like create user groups, have them run like software without granting them unnecessary privileges, and potentially change like your SSH ports. 22 is what SSH generally uses. You can change it whatever you want in your config, and it's often a good idea to do that because people are constantly scanning 22 to see if there are any vulnerabilities there. I set up different user groups. I changed the SSH ports, and because these days I have my consensus layer clients on a different machine than my execution layer clients, I also I'm very careful about like which ports I expose. So you can modify the ports that the engine API uses, and it might be worth doing that. But I think that that's really probably unnecessary. Just as long as you make sure that all of your ports are closed except the ports that need to be open for communication from your nodes to the blockchain and potentially between the execution layer and consensus layer. If you are running them on different machines, make sure that those ports are only open for one IP address, not a whole range, and potentially, customize your machine so that you SSH in on a different ports other than 22. And people will probably watch this recording and be like, you didn't mention 100 other basic things that should happen with security. There's good documentation both on the ETHStaker sites and in the Rocket Pool docs for kind of like how to lock, in particular, a Linux VM down in the cloud. And I would follow that quite carefully. The basics is like have a firewall, close everything down, only open the specific ports that you need, and only open them to the specific IPs that need it.
Yes. And I think doing your own research, like you just mentioned, right? Being prepared. It's definitely a journey that I hope many people take up after this session. I'm excited for all of the cross collaboration between the different communities and how to get this set up, because there's definitely interest that I hear from different communities, but then they don't have someone around them that's also interested. And so one of my hopes after the session is that we are able to actually identify the people that want to learn together and create working groups, and then venture off, and then they'll have more questions for you, Andy.
Sure.
Yeah.
There's another that Kenzu presented Kernel recently called OBOL, OBOL.
Yes.
OBOL,
Yes.
and like they might also be worth looking into. I haven't used them though, that's why I haven't talked about them in this call, because I don't know, therefore can't say much more. But that's maybe also like a good place to go looking for that kind of collaborative way of running nodes.
So I have a bit of a bold question, because I think you have an understanding of Ethereum before its upgrade and Ethereum post its upgrade. Do you think upgrading to proof of stake was a mistake in terms of scalability? Is it now? Are we at a point that it's too confusing, and or maybe what are your thoughts on this, and then we can talk about scalability.
Yeah, short answer, no. Like very obviously not a mistake, because proof of work was just like it was not going to last, right? Like state bloat and the rate at which the chain is growing, it doesn't. It's not possible. It's not really like proof of stake totally solves that, but it did help enormously. It also helped enormously with energy costs, both of which I think are like important.
What do you think the merge still hasn't solved? What do you think the merge still hasn't solved?
Yeah, I mean, there's lots of things, right? There's lots of things that still have, I think, a great deal of work, like generational work, right? I don't think that there are some things that are just not easily solvable, and a lot of the things that are easily solvable have been attended to in the past 10 years, and a lot of the things that are left over bleed out of the realm of protocol design and engineering into the realm of politics, basically, right? And that what you inevitably end up seeing is the complexification of like the network as a result of its increasing entanglement with the world of which it is a part, right? That is to say that as Ethereum gets more users and there's more value associated with it, and more people are actively like thinking about and using it, it inevitably brings a great deal of like complexity to sort of how the thing works, because there's just so many more people using it. Like you see this kind of stuff, right? With like MEV is probably the best way to kind of like illustrate this, even though it's supposedly a complex topic. the basic point here is that like we have recognized in the past 10 years that the mere fact that there are particular ways in which you can order transactions has value associated with it, right? In some way, this is like the latent financial energy of the system. Just the fact that there are multiple possible orders for any given set of transactions in a given time period. The question is, what is the best way of ordering those, right? And it's an enormously complicated question because it touches on things that have actually existed far before blockchains did, right? Like, in fact, the first example of MEV that we know about occurred between Paris and Bordeaux in the 1800s, because there were two brothers in Bordeaux who figured out how to bribe the telegram operators in Paris and Bordeaux to send signals about the prices of stocks via telegram in the days when the stock prices were still communicated by horse carriage. It took 3 days to ride from Paris to Bordeaux, but telegrams obviously get there much, much more quickly. And so what telegram operators would do, they bribe the guys in Paris to insert a signal about whether a particular stock was going up or down, and then backspace it. Because like that's how telegrams used to work. You would like type the characters, and if you made a mistake as the operator, you would just send a backspace, and then the operator on the other side would know to like not print that character. So at the end of each telegram, they would like send a character that said up or down, and then backspace it. And then they bribed the guys in Bordeaux to tell them what the backspaced character was, and they would then backspace it and send the telegram on to its intended recipient. And they made a killing, right? Because they had asymmetrical access to price information. Which is exactly why the reason that the order of transactions in any given block has a value associated with it, because you can order it in a number of different ways, each of which has a different result for the profit of various different people. All of those people have conflicting economic interests. And the question is, well, how do you design mechanisms that result in the most fair ordering of transactions such that everybody kind of gets what they want and receives the value associated with it? And that is not just a protocol question. It's an engineering, and it's not just an engineering question, although it's also those things. But there are political aspects to it, right? And that's kind of interesting to notice. And I think that's inevitably, if you think that like Ethereum is like some kind of martyr technology that's going to save the world, you will always find problems with it. Right? If you think that it is an interesting evolution in distributed systems that is capable of introducing, of broadening access to global markets and allowing people to participate more on their own terms in a censorship-resistant manner that has very, very specific features associated with it, then I think that we're a long way towards achieving that. But some of the biggest problems that we still face are the centralization in the builder markets, the complexity of the changes required to attend to that proposal builder separation or inclusion lists or execution auctions, or there's a plethora of research possibilities. Justin would have talked about it in more detail than I will. But each of those things is a big part of it. I think that's to kind of touch on your original question. The inevitable fragmentation into like multiple different places is not a problem, but it does represent real big challenges at the moment in terms of like the user experience, which is something that people always talk about. And I think that it's worth kind of noticing that. I think that it's also eminently solvable with a very simple EIP that just introduces the chain ID prior to your address. But more generally, I think that a lot of the I see two big streams of work and research outside of those like very traditional answers to this question that you've asked, and the one is kind of interoperability writ large. I think that's interoperability is again a very, very technical question and a political one. Right? Because I don't just mean between EVM chains and L2s, I also mean between other networks. And I think that that's kind of exciting, and it touches on what I was saying. Like if running Ethereum node in your particular locality doesn't work, run something else, because hopefully these things will all be able to talk to one another in a meaningful way in the near future. And the other thing that I see as a big thing is the spectrum of trust, right? Don't trust, verify. I know that you probably have to go, and I've probably taken too much time already, but there is a whole spectrum of trust. Blockchains are on one end of it. Centralized limit order books are probably on the other. And I think that there is like really an entire space in between there, which we're beginning to see navigated by trusted execution enclaves. And things like SGX or SEV or TDX, these kinds of things provide really interesting halfway points or specific guarantees on trust and privacy that you wouldn't be able to otherwise get from just a public blockchain. And the most pertinent example of this kind of stuff is something called cycles.money from Cosmos. Ethan Buchman is the man behind it. So if you go to cycles.money, you'll see what I'm talking about. They have combined trusted execution enclaves with zero knowledge proofs. And the reason that I mention them, and then I really will stop, I'm so sorry. The reason that I mention them is because they've combined TEEs with zero knowledge proofs to focus on liabilities, the liability side of the balance sheets. And cryptocurrency people are completely obsessed with assets, and we hardly ever think about liabilities. And liabilities is where the real power lies on your balance sheet. And this is like the final points that Ethereum hasn't solved. Nobody's solved it yet, because everybody will say money is the killer app. Well, show me the money that changes the world, right? That's the biggest problem. Like, why has nobody solved that? We have spent freaking nearly 2 hours here talking about deep technical topics like how to run a node. And that's wonderful. I love all of that. But where's the freaking money that's supposed to save the world? Anyway, Ethan might be building it. We've had some fun, hacking on that kind of stuff in Kernel. And I think that, really peering into what we in the cryptocurrency world sort of perceive as the shadow side of money, debt and liabilities, is going to be like a very, very important part of how the networks evolve over the next 10 to 20 years, and might even play a role in interoperability. Those two things are actually very deeply linked. The interoperability, the spectrum of trust, and the kinds of money that it allows us to make, and the impact that way of representing money might have in the world are unsolved problems, things that are being worked on, and probably the most exciting direction, as far as I'm concerned, both in terms of research and implementation. Because a lot of the stuff that you'll see purely on ETH research, whatever, while it's really interesting and very technical, you need the big why. You need the big why, and you need other people who care about it. And I sometimes wonder if the depth, specificity, and precision of the work that we've been doing hasn't sometimes obscured that picture for a bit.
I didn't want to interrupt your session, but my laptop was dying and I needed my adapter, because I always forget. I have my charger, but I always forget my adapter in foreign countries. So sorry if it made you feel like we needed to go. Really, we actually want to be mindful more of your time, because when we started this session, we could see you very clearly, and now I can see that it's getting dark. Yeah. Yeah. Yeah.
Cool. Well, thank you very much.
Yeah. So one last question though, Andy. Can we expect to see you at ETH Safari? We know that Yosef will actually be there for sure. And I don't know, is South Africa far from Kenya? Too far for you to join us?
Yeah, it's not far. It's like a 4.5-hour flight. But I'm not sure that I will be coming up, just because I have a newborn son.
What?
Travel is. Thank you so much. So travel is a little bit more challenging at the moment. We'll see. Things are in flux. But I will be with you in spirit. That's for sure. Whether my body makes it there, we'll see. But my priority at the moment is very much my family. So.
Wow, this is so exciting.
Yeah. Yeah, exactly. That's why I need to go, because it's time to go attend to him.
Yes. Well, thank you so
Thank you very
much,
much.
Andy. People are saying congratulations to you in the chat. I will share your Twitter, because I think that's the only place that we can find you, Crypto Wanderer. It's also a good time to note that there is a kernel block happening right now that ends in September. But if you are interested in learning more about the lessons behind Kernel and some of the topics that we didn't even get to address, all of the Kernel curriculum is actually online and public, and yeah. So I linked to that Kernel community, and I'll also link it in the WhatsApp group that we've started. But yeah, so if you're interested to learn, yeah, go ahead.
Yeah, just send my email address, because Twitter, I'm unlikely to respond there, because I don't spend any time there. So just if you want to talk with me, email, and I'll be there.
Yes.
Cool.
Yes. Thank you, Crypto Wanderer.
Yeah.
Bye. Oh, amazing. So I'll just end off the session by saying thank you to everyone that joined in, that still is tuning in. Let me change the format of this. This looks much better. I think with something, there's so much that we didn't even get to touch on in this session, mainly around what are the ways that you as an African can contribute to actually, so there's like one part of it which we talked a lot about, which is the financial incentive of decentralization and of running a node. Like I said, my wish is that you guys get together and actually create a working group between one member in Ghana and one member in Uganda and one member in South Africa that actually are serious about wanting to take on this challenge. I think we've learned many ways that we can accomplish this as a collective. And then, some of the parts of the talk that we didn't get a chance to dive deep into with Andy is what does it even mean? We touched the surface, right? But what does it even mean to participate in decentralization, and why does it even matter more in Africa? Yeah, I think this is a conversation that we can continue in all of the in real life events that are happening. So like I said, this is an initiative to kind of highlight, to bring us together in a virtual capacity, but that's leading up to all of the in real life events that are happening. And so again, there's ETH Accra that's at the end of this month. Time is flying by because there's only like 3 more weeks left until ETH Accra. So if you haven't already signed up, ETH Accra is the first hackathon that you can participate in. And then next up, you have Web3 Lagos, which is just 1 week after, in the first week of September. And then, of course, we have ETH Safari. So it's going to be the second week of September. If you haven't already, thought about coming to Kenya, you really should. It's going to be the largest hackathon and conference yet. So it's from September 8th to the 15th. And if you're looking for opportunities to attend, Cartesi is actually supporting developers that want to learn more about Linux and how to actually build dApps on Linux on the blockchain, but like using a very Web 2 language. You can check out their Udemy course. It's about an hour and a half long. And then they have a full-on masterclass in Kenya right before our hackathon. And so it's a really good opportunity for you to learn in person with a teacher in a small working environment. And so if this is something that you're interested in, I would highly, highly recommend that you check out the Udemy course from Cartesi. And then start learning, start building. And then, of course, right after ETH Safari, there's also ETH Cape Town. So all the friends from ABC, I know you're a little bit far away in Johannesburg, but I will actually be attending ETH Cape Town. Yes, there's all these in real life opportunities. Next week, we have a session on how to build smart contracts. And so if you're listening and don't really have that technical knowledge and want to learn a little bit more, or if you're listening and you think you know it all about building smart contracts, I'd invite you to actually get prepared next week to follow along to Faith, who'll be running a session on how to run smart contracts. So how to deploy smart contracts. So always thankful for people that tune in, and I will see you next week on On-Chain Safari. Uganda or Accra, do you have anything to share before we end this live stream? It's okay if you don't. Good. I'll see you guys next week.
No,
Bye.
see you too. Bye.
See ya.